Hello everyone, welcome back to our playlist on object-oriented programming in C++. In this video, we'll be learning about constructors. The topics which will be covered in today's video are what are constructors, types of constructors, what are destructors, and lastly, we'll see user-defined destructors. Now, what are constructors? A constructor is a special member function of a class. It is called at the time of object creation. It has the same name as the class name and it doesn't have any return type. Now, a question might be arised in your mind that earlier when we created objects, we never used constructors. So keep this question in mind, we'll get back to it later on. Now, let's see the syntax of a constructor. I have created a class ABC here and this is the constructor of it. The name of the constructor is same as the class name ABC. Then it is followed by parameter and later on the body of the constructor. Now, why are the constructors used? They are used to initialize the objects with its initial stage. In other words, we can say that it helps us to initialize the data members of the objects of that class. I know we already did it using the dot operators previously, but the main advantage of a constructor is that it can provide a fully initialized usable object upon its creation. Now, what do I mean by usable object upon its creation? Let's see it in the code. I have created a class vehicle here. Now let us add some class members to it. The int wheels variable will contain the number of wheels the vehicle has. And the string color will store the color of that particular vehicle. Now let's create an object for the class vehicle. Now this is the object declaration. Now let's add the data members to it. Okay, so we have declared an object here and later on initialized its data members. But if we use the constructors, we don't need to add these two statements. We can initialize the data members to the object at the time of its declaration only. Now let us have a look at the type of constructors. First, we have the default constructor. A default constructor is the one which doesn't have any parameters. Now getting back to the question that while object declaration we never defined a constructor. So even if you don't define a constructor, the compiler will automatically provide you with a default one with some default values of the data. Before defining a default constructor of our own, let's see how does the predefined default constructor works. I will delete the initialization of the v1 object which we did earlier. Now let us see what default values does the default constructor of the class vehicles gives for integer wheels. Let's run it. Now you can see here that the default constructor of the class vehicle gives us a garbage value for the v1.wheels. Let us define a constructor of our own. Now as a programmer, you want that whenever a user creates an object of the class vehicle, you want the default value of the integer wheels as 0 and the string color as none. Now let us print the value of the data members again. Now you can see here as the default constructor is called when we create an object v1 and the default values of the data members are given to the object by this default constructor. v1.wheels gives us 0 as we defined here and v1.color gives us none as we have defined it in the default constructor of the vehicle. The next type is the parameterized constructor. A constructor with parameters is known as parameterized constructor. A parameterized constructor is used to initialize distinct value to the different data variables of the object. What I mean by this is that we have to use the default values defined by the programmer, but by using the parameterized constructor, we can initialize the data members according to the user. Let us now define a parameterized constructor. Now what I did here is known as the constructor overloading. It is same as the function overloading, where the name of the constructor is same as the class name and we can have different parameters to it. I will use integer x to initialize the wheels and string y to initialize the color. Now let us create a second object. As the parameters contains integer and string value, we need to add it to the same while declaring an object. Now let's print the values of v2. We can see from the output that when we declare the object v2 with parameters, the parameterized constructor is called. Now to see which constructor is called when, let us print something in the constructors. Now let us run it again. We can see that first the vehicle v1 is created, so it goes inside the default constructor, and when we declare the object v2, the parameterized constructor is called. The third type is the copy constructor. A copy constructor is used to copy the data members of one object to the other. Imagine you go to a stationery and ask the owner that you want a marker same as this one, that is with the same ink and of the same brand. The owner will then take a look at your old marker and give you a new one. This marker will be exactly similar to what you showed him. This is what exactly the copy constructor do for us. It will create a new object, but it will have the properties as some other object defined earlier. Now let us declare a copy constructor, the parameter of which will have a reference object of the class vehicle. The wheels of this new object will have the number of wheels similar to that of the object obj, and the color same as that. Now let us create a third object. Now let us run it. Okay, I misspelled vehicle. Now you can see that the vehicle v3 has similar data members initialized as that of v2. Now let us see what are destructors. Destructors are the special member functions which are used to delete or destroy the objects. The constructors are used to create the objects, while the destructors are used to destroy the objects. It has the same name as the class name, but unlike constructor, it has a tilde sign added before its name. They are called when the object goes out of the scope. Out of the scope means either the end of the function or end of the program, or when we use the delete operator. Now let us see its syntax. Here I have created a class ABC, and this is the destructor of class ABC. One should remember that there are no parameters to be passed along with the destructor. For now, I'll be only using one of the objects, that is V2, and let's create our destructor here. Now let us run the program. The first line is printed when we create an object. While creating an object, this particular constructor is called and this line is printed. At the end of the program, the object V2 gets out of scope, and that's when the destructor is called. Remember, you don't need to define a destructor of your own. Compiler provides you with a default destructor even if you don't define it. But in some cases, you need to define your own destructor. Now, let's see when do we need to define a destructor explicitly. First one, using dynamic memory allocation functions in the program. And the second one, when you are using pointers or referencing to access data members. But what actually happens? If you are doing dynamic programming, you need to allocate some memory for something. And later on, it is the job of the programmer to deallocate that specific memory. If that is not deallocated, it may lead to memory leak. Now, what is memory leak? Memory leak occurs when the memory is allocated dynamically and not deallocated again. This part of the memory cannot be used by the program as it is not deallocated earlier and is reserved for nothing. It will result in reducing the performance of the computer by reducing the amount of the available memory for use. We'll create a new object here. Now we'll use pointers which dynamically allocates memory to the objects. This will dynamically create an object and call the default constructor. Let's run it. Now you can see here as the memory was allocated dynamically, only the constructor was called and not the destructor. As we have allocated the memory dynamically, we need to deallocate it using the delete operator. And when we do this, first the constructor is called and then the destructor is called. This was just to show you that the delete operator calls the destructor. Let us delete this for now. You actually don't need to define a destructor here also because you are allocating and deallocating the memory in the same function. But what if you are allocating the memory when the constructor is called? Let's add a pointer to the members in seats. Now I'll be allocating the memory for this particular number of seats. And then I will use the delete operator to deallocate the memory for the seats. Now let us understand this. When you create an object, this default constructor is called and the memory is allocated to the variable seat. As you know that the memory which is allocated needs to be deallocated later on when it is not in use so that the memory leak doesn't happen. So when we delete this object reference, its destructor will be called, and when the destructor is called, the memory allocated to the seats will get deallocated using the delete operator. We have added this inside the destructor so that the memory is deallocated only when the object gets destroyed, not before that. And that is why we sometimes need to define our own destructor. Thank you.